Welcome back, Math and Beats. Today it's time for another math video. We're going to talk about what interval notation is, since it's used so commonly in mathematics. What is interval notation? Let's get right into it. Well, interval notation, as we see here in this description, is used to describe sets of real numbers which start at one real number and end at another real number, and also include all values in between. So there are different ways that this happens, and we are going to go ahead and write them down now and then try a few practice problems. So it's just a notation to describe sets of real numbers and all of the real numbers in between those two real numbers. So how do we write it? Well, first of all, we're going to draw a little diagram here and organize all the different ways it can happen. So on the left, we're going to just describe a set. We'll use set builder notation to describe the set. Then we'll write the corresponding interval notation. And then also we will draw a little graph depicting such an idea. So here's some sets, and we'll just run right through them. First set, say we have the set of some numbers, say x's, and x is real, and maybe x is between two numbers a and b. So here we're going to assume for our description a and b are real numbers. All right, so you see we want to describe the set of all these real numbers that are between a and b, but we do not include the a or b. So the way that we write that is as follows. We write a parenthesis, a, comma, b, another parenthesis. And I know that that can look a little confusing since that's a very similar notation to what we use for ordered pairs, but we just have to know the context when using the interval notation versus an ordered pair. Ordered pair is used for plotting a point in the Cartesian plane. Here we're describing a set of real numbers. So that's how we write it. We always read left to right. We're starting at A, not including it, and then moving through all the numbers from A up to B. The graph of this is a number line. So maybe this is a bunch of X's here. And what we would do is there's actually two ways to describe this. We can either draw a little hole at A and another little hole at B, and then shade everything in between them. That's one way to write this. Another way to write this, could write or, whoop, get out of here, is we actually draw those parentheses. So maybe a parenthesis there and a parenthesis there, and then shade everything in between. Either one is acceptable. We use those little hole looking things to denote the idea that A and B are not included, which is analogous to writing the parentheses. So that's one combination we could have. But consider now the next scenario in which we have the set of real valued x's, but now we're going to write x is between A and B and include the A and B, hence the less than or equal to signs between the x's and these other values A and B. The way we would denote that in interval notation is always some number, comma, another number, but like in the first part above, we use parentheses because we do not include the A and the B. In this one, we use brackets, as we say. That bracket helps us understand that we do include, as we say, the endpoints A and B of the interval. So up here at the top right, we're just going to write a little note. Parentheses. These are used when not including the endpoints. And then we use brackets These are used when including the endpoints. And that's a big part of the notation in general. So when we graph this interval, we just wrote down a to b, including the endpoints with the brackets. Instead of writing little open circles like we did in the first part, we could just draw closed circles to denote that we are including those values. And then we shade everything in between. Likewise, if we wanted to draw it with the brackets, say from A to B, including the endpoints from left to right, A to B. So those are two ways that an interval of real numbers can happen. We include the endpoints or not, and then sometimes it ends up that we have one endpoint included and not the other. So for instance, what if we have a collection of real valued x's where we include the a, but we don't include the b? Then the interval notation of that is, well, where we include, we put bracket. So we put the bracket at a, comma, we go all the way up to b, but then we put a parenthesis on b because we don't include the b. As a graph, the two different ways to draw this, we draw a closed little dot here at a, since we include it, then we draw an open dot or hole at b. And then, of course, everything between these two things. Likewise, with the brackets and the parentheses, we'd put a bracket at a parenthesis at b, and shade everything in between. And then the last combo we could have is just the other way around. We include the right hand endpoint but not the left. So say we have a collection of real number x's, and then x can be bigger than a, but now less than or equal to b. Forgot to draw the bracket up there. All right. Well, we would put an a, comma, b as usual, but this time we'll put a parenthesis at a and a bracket in b, since we're including the b and not the a. Graphically, on the number line, we would draw now a hole at a, and then a closed dot at b, and then shade everything in between. Or we could draw the number line depicting this set as a parenthesis at a bracket at b, and everything in between. So that's the four different combos when you have endpoints that are real numbers and using interval notation. So you see the interval notation, you either use parentheses or brackets. You read from left to right, the left side being the smaller of the values, the right side being the larger of the values. And then if it's a parenthesis, that means you're not including the a or the b, the endpoints, and if it's a bracket, that means you are including that endpoint. So there's a couple more we'll see in a moment, but first let's just do a couple quick examples. For instance, I'm going to switch colors now. How about green? Everybody loves green. Let's, for the following example, let's write each set in interval notation, and let's graph. So it's going to be very similar to the generic description that we just gave above, but we're just going to throw in some actual numbers. How about for the first one, let's just say the collection of real valued x's. So x is real, where x is bigger than -1 and less than or equal to 4. So an interval notation, that would give us, all right, we start at -1, include all the numbers all the way up to 4. We include the 4. We do not include the -1. So, and then the graph of this would be, I'm going to use the brackets and the parentheses here in my graphs, but you can use open or closed dots as well. Just start at -1, end at 4, and then of course everything in between. Something like that. Or, you know, for instance, what if you had some set of real numbers and maybe, I don't know, 3 is less than or equal to x is less than or equal to pi. Then, as an interval, we would start at 3, we would end at pi, and then here we include the 3 and the pi, so brackets on each of them. Draw a graph of this, start at 3, end at pi, brackets on each, shade everything in between. All right, the other two possibilities, how about x? X is real. And how about negative 4 is less than x is less than 7? Then the interval notation for that, start at negative 4, go all the way up to 7, include everything in between, but we do not include the negative 4 or 7, so parentheses on both. And then we would draw the interval, parentheses as so, from negative 4 to 7. Finally, the last combo. How about some x's? X is real. And now this time we're going to go from 6.25 less than or equal to x and x less than 10.1. Then the interval notation for that would be 6.25 up to 10.1. We include the 6.25. We do not include the 10.1, and the interval 6.25 to 10.1 include the 6.25, do not include the 10.1. So there you go. There's a few examples of using the interval notation to describe a set. It's mostly useful just because it's a very condensed version of a set builder notation. We could always use both, but interval notation is commonly used in math. All right, now there's a couple more scenarios that can happen here, and that is if your real number is in an interval where at least one side of the interval grows with magnitude. So that is, what if we had a set that looked like so? Say we have a collection of real numbers x, where now we just say x is bigger than some number a. So you say, okay, well, it's going from a, and then we're moving along to the right, bigger and bigger and bigger and bigger and bigger and bigger and bigger values, and they just keep getting bigger. So in that case, because we include everything bigger than a, our right-hand side of this interval would actually be infinity, because we're letting it grow without bound here. Since we do not include the a, we put a parenthesis, and then, rule of thumb, you never, ever, ever, ever put a bracket on a parenthesis. So always or a bracket on an infinity, you always put a parenthesis on an infinity or a negative infinity, because that is not a real number. It's just you could approach that direction, you can never actually get there by definition of infinity. So as a graph, we would draw something like, well, here's a, we don't include it, and then it just goes this way forever. You could put a little arrow in your graph to denote that we just keep on going. So a similar thing can happen if, say, here's a set of real number x's, but now let's say, well, x is less than or equal to a. Then here the right-hand endpoint is the real number a, and we include it, but then we can go to the left as far as we want. You count down to the left on a number line, that approaches the direction of negative infinity. We could keep going down that direction forever, and just like above, we always put a parenthesis on an infinity. Since it is not a real number, we can obtain that value. So in a graph like this, it would look something more like, here is a, we're including it, and we go any number down there as far as we want to the left towards negative infinity. What if you had this happen on both sides, that is, go to infinity and negative infinity, say x is real, and you just say x is any number. It can go to infinity, It can go down to negative infinity and anything in between. Any real number x's. Actually, this set right here is just all the real numbers. So the way we denote that using interval notation goes far down to the left to negative infinity as we want, and as far up to the right to infinity we want. So both sides of this interval are going to be a parenthesis since both have unbounded values. And then the way you would draw that is just be like, well, it's the whole real number line. It's all of that stuff. Couple quick examples before we finish the video. How about we do the same thing like we did in the previous example? Let's write each set using interval notation and graph. Okay, so I'll make a couple up here. How about the first one? Set of real x's, where we have that x is bigger than or equal to negative 7. Then this is like that first scenario in red above. That is, we're starting at negative 7. We're including it, and we can get any number bigger than that as well. So towards infinity. And that's it. Put the parenthesis on the infinity, bracket on the negative 7. We then graph it. Somewhere down here is negative 7. We draw a bracket to denote that, and then anything to the right. And there we go. A couple more. How about x? X is real, set of real x's such that x is less than 15. Then we know our right hand endpoint is 15. We're going to put a parenthesis on there because we don't include it. We go anywhere to the left down towards negative infinity, parenthesis on that one as well because it's an unbounded idea. Graphically, here's the 15. Draw a little, whoops, we're using a parenthesis here. Draw a parenthesis and everything to the left. All right. And then finally, let's just be like, x is real. And that's it. That's a whole set. There's no restrictions. That would mean an interval notation. It'd just be all the real numbers down from negative infinity up to infinity. Don't include those endpoints, put parentheses, and then you just draw a real number line. It's everything. So those are the various ways that we can write an interval of real numbers. This is always for a collection of real numbers where we have somewhere it starts, somewhere it ends, and we include everything in between. Whether or not we include the endpoints of the interval all depend on whether or not the endpoints are included. And if you include the endpoint, you use a bracket. If you don't include an endpoint, use a parenthesis. So that's how we introduce this idea in this video. These intervals are used all the time in math, so it's nice to kind of knock this out of the way at the get-go here, and so we can use it going forward. And that's it. So hopefully the interval notation video helped you, and we're done with the video. It is Math and Beats. Subscribe and like it, and it's now time for Beats. Later.